1953, Dr. Edward Colin Cherry found that people can reject noise they did not want to hear in order to focus on a specific conversation or noise, and he called this the cocktail party effect. Cherry himself was mainly interested in the ability of listeners to select target speech while ignoring the other sounds and conditions where signals were either mixed or presented to separate ears. His work acted as a starting point of a line of research into selective attention, which generated influential early filter models from Broadbent in 1958 and Anne Treisman in 1964. This also led to later work that mainly focused on auditory attention effects and speech perception. The cocktail party effect describes the brain's ability to focus attention on a single talker among a mixture of conversations and background noise. An example of this is when conversing at a musical concert, people can listen to a band and understand a friend all at the same time. They can also simultaneously ignore loud noises. However, if someone calls out your name from across the room, you will notice. The human auditory system is able to ignore most of the reflected sound because it arrives from other directions than the direct sound. It also can switch the direction of attention and turn from one sound source to another. Research has suggested that in order to use the cocktail party effect, the auditory system performs a kind of cross-correlation function between both ear signals. This works best if the person has hearing in both ears. The human pinna, the external flap of skin and cartilage of the ear, is used as a directional filter that selectively removes particular sound frequencies based on the area from which the noise comes. The filter can distinguish sounds from above versus below and from front versus back. Neurosurgeon Edward Chang and Dr. Nima Mesgrani worked with 3 patients undergoing brain surgery for severe epileptic seizures. Part of the surgery involves pinpointing the parts of the brain responsible for disabling seizures. What they do is take a thin sheet of 256 electrodes and place it under the skull on the outer layer of the brain cortex. These electrodes record activity in the temporal lobe, home to the auditory cortex. The 2 then hosted this experiment with 3 patients, where the patients listened to 2 speech samples, played to them simultaneously in which different phrases were spoken by different speakers. They were then asked to identify the words they heard spoken by one of the 2 speakers.
There was a very stylish emperor. He changed his clothes many times a day. I want to wear something fancier, the emperor said to himself in front of the mirror.
You either heard off of that recording the Emperor New Clothes story or the political speech. And that is an example of your selective hearing. They found that their decoding algorithm that they came up with could predict which speaker and even what specific words the patient was listening to based on the neural patterns. In other words, they could tell when the listener's attention strayed to another speaker. New research shows that the representation of speech in the cortex does not just reflect the entire external acoustic environment, but instead just what we really want or need to hear. This represents a major advance in understanding how the human brain processes language, with immediate implications for the study of impairment during aging, attention deficit disorder, autism, and language learning disorders.